Hello there. Hi. Um, Welcome to my stream. My name is Darren, and I do software development and play a lot of games and study how to apply the things that I learn in games into my personal and my professional life. And for me, it's doing quite well. Um, Super fun. I love learning. And today, we're going to be learning, um, we're going to be studying Solana. So we've been doing some Solana Anchor Framework tutorials recently. So we'll do that again for an hour up to right now it's 7 p.m. in the Philippines. And we're going to be doing this until 8 in the evening. So yeah, let's figure out how to actually do some smart contract development on the Solana network. Let's go. I'm just gonna close off some windows that shouldn't be open, and then we can probably get started. Okay. We'll move all of this on the left. There's some other stuff that I also want to share, which I think are super interesting. So we'll see. Okay. So we open this up, and yeah, let's get started. We're gonna put this back on. Okay. And we're gonna be doing some Solana development. So let's just pull up the tutorial we were following last time. I think it was Anchor, right? Anchor docs. Yep, tic-tac-toe. All right, let's just go ahead and get straight to it. If you guys have any questions or you want to have a little chat, just feel free to throw some questions down on chat. So yeah, let's go. Honestly, I can't remember what the last context was of what I was doing, so I think I was here on this part of the Anchor tutorial. So last we basically provided some fixes for some GitHub here, right? This one was actually a problem. It had some type issues, and we fixed that up. We fixed it and referenced it in this way. So the play instruction, let's start from this context. Playing the game. So how do you play the game? So we're building a tic-tac-toe application on the smart contract on Solana, and we are using the Anchor framework to do testing from a client perspective, right? We're building the smart contract, or the game application itself, on the smart contract built using Rust, and it's operating on the Solana network. But we're using TypeScript as its client, right? So on the TypeScript unit test, or test basically, we have these ways to set up the game and verify that the game is properly set up, and double checking if things actually work. Yeah. So moving on, playing the game. The play accounts struct is straightforward. So again, if you haven't been able to follow along from previous session, accounts is the mechanism on Solana to actually record and hold data on the blockchain network. So that's their account system. And other things that you can read about it is Solana Cloudbreak, right? Horizontally scaled state management, or state architecture. Okie dokie. So the play account, so let's look for that. I think we already have that. Let's move this to the right side, and let's read this one up here. So let's go to the library and let's look for play. So we did a bit of freshening up on Rust on the previous streams, so we get to actually understand a little bit more on what these actually mean. So there's a public struct play. So we have this one here, and player needs to sign, or someone else could play for the player. Finally, we add the play function. Do we have this play function? fn play? Yes. We add the play function inside the program module. We have the program module called anchor hello world, and we define the play functionality. And the play functionality, so I'm just practicing being able to read Rust right now because I'm not so familiar with Rust yet. So okay, reading this, we have a public function called play that receives a context. And the context gives you access to play, which is an account, right? It's a definition of an account. So it's a data structure, right? So an account is a data structure of validated accounts that can be deserialized from the input to a Solana program. The implementations of this trait should perform any and all requisite constraint checks on the accounts to ensure the accounts maintain any invariants required for the program to run securely. In most cases, it's recommended to use the accounts derive macro, right, to implement this trait. So we get that data structure, and then we also have tile, right? And then this is supposed to return a result. And what it does is it gets a reference to the game, which is a address of a mutable game, which is basically the account, right? Following the game structure. So we get reference to the game, and then this one, I think we've checked in the account struct that the player's account has signed the transaction, but we do not check that it is the player we expect. That's what the requires keys equality check in play is for. So it's double checking that the person playing this turn is actually the current player that's specified. Otherwise, it's going to throw this specific error, which is an enum. We studied this last session, how to define enums. And these are the different types of enums that's supported. And this one is just throwing that tic-tac-toe error that it's not your turn. Okie dokie. Hey, my friend Will is here. Hello, sir. Hello. Some Solana development. So we're just tying in what we studied from last session on Rust, the Rust language. And now we're applying it basically on the Anchor framework, which is this framework that we're building for... the Anchor framework is this thing that we're using to make it easier for us to actually build smart contracts on the Solana network. So yeah. And after we do that assertion check, right, we run the play function, which returns a result. And there's no semicolon here because it's going to be returning that value as the return type or return value of this function. Then the plays parameter has a reference to itself, which is the program itself and the tile. The game has a function. The game object, the game account, has a play function. So the game structure, right? If you look at that, the game structure has an implementation and it has a play function, right? That's what it's gonna do. Okay, moving on. Testing the play instructions. Testing the play instructions works the exact same way. To avoid repeating yourself, create a helper function at the top of the test file. And yes, we did this. Did I put it at the top or I didn't? Async function. No, this is JavaScript code already. Asynchronous function, await. This is all JavaScript code. So we're gonna be checking the JavaScript or TypeScript section of our code. And it has this play functionality, which receives what program we're actually working with, which is the Anchor Hello World program that I have. And then it has the game reference, the player reference, the tile reference, the expected turn, expected game state, expected board. Okie dokie. So I think we just copy pasted this one, await program methods. So the program has a set of methods, things that it can do. And then if we do control space here, it should have autocompletes to set up the game or to play the game. And now we are going to say which tile it's actually going to play. And then the account that's going to be doing this is this specified player and the reference to the game. And then the signers is, if it's an instance of an Anchor wallet, then it'd be nothing, but otherwise it would be the player. I'm not sure what signers in RPC means. I don't know what the signers is for. Maybe it's like who's paying for it, I guess. I guess that's the question. It's either, if it is specified, if it's an Anchor wallet, then it's left blank. And my best guess is that the owner of the game or the person who initiated the game is the one that's going to be spending for the processing. Otherwise, if you specify a player that isn't an Anchor wallet, which is basically another player, right? That player would be the one to spend for playing the game. And then .rpc, I think this just means remote procedure call. So that just triggers the call to the Solana network to actually do the whole thing. Just best guesses. My confidence level for this is maybe 60%. 60%, maybe that's right. Constant game state. Okay, so we have the program. We get the account, we game the account's game, then we fetch the game. Then we have the game state. We can check the turns. It's supposed to match this expected turn, this game state, and the board. Now I want to actually run this again. I just can't remember. Oh, it's anchor test. So let's do that. Right? Let's just double check what this thing currently does. So anchor test basically builds your smart contract, deploys the smart contract on your local test net, right, which is your local environment, runs the application, the TypeScript application, and then decommissions the local testnet blockchain network running on your local machine. So the first test worked, setup game, but the second test, player one wins, fails. So it is expecting null to deeply equal x something something, right? So it was expecting this one, but it found this one. So let's go check the expectations for player one wins. So I think it failed the expectation here. Okay. It generated a new game key pair. It set up the game and then it ran the game. So supposedly this should be a completely new game. So this should actually be fine. It should reset actually. So what it's saying is that this is at line 108. So this isn't matching. It was still null. Okay, so it's this part, right? So these assertions worked, but then when we try to play the first turn, it actually doesn't work. So let's try to figure out how to fix that. Play. So to play the game, it says specify the program, specify the public key of the application or the smart contract, I think. It's the reference to what the reference to the game state, right? The public key of the game. Specify who's playing, so player one. Specify the tile, and then the expected turn should be 2. Then there should be the active game state, and the board should look something like this. And this passed, this worked actually. But when we try to run these expectations, these ones aren't working. I'm just curious. I think it's because we need to fetch the game state again, I think, because we introduced some changes, right? Currently in memory, that game state wouldn't have changed. So I think we need to fetch it again, get the current state. I think this should be now equal to 2. The game state should still be equal, should still be active, and this should now have this state. So let's see if that works. Okay, it's now working. Let's read. Player 1 wins, anchor error code tile already set. Error code number 6001. This is curious. Well, which part of the code did it fail? saying tile already set. So when we start, we generate the game state, and then we take a turn, right? The game state should be empty. Then we play the turn, update the game state, then it should be okay. So I'm gonna go ahead and comment this part first and see if it actually passes. Let's take it one at a time. So it works. So it's actually play turn 2, which is failing. So let's fix that one. So on play turn 2, you basically can't set the same row, right? So if we say row 0, column 1, then we expect the game state turn to be equal to 2, and then it should be like this. Actually, these are already checking the assertions, I think, because that's what the play is for. It's checking the expected turn, expected game state, expected board. So I'm gonna go ahead and remove this part. We don't need duplicate assertions. Yeah. Yep. So you just keep running play. I think that's what his whole point is here, right? Like define it as play so that it's easy to find out what's going on. So I'll just run anchor test again. Okay. It was expected to be 3, but it was equal to 2. Right. So this is game state 0. I think this should be 1, I think. Line 28. This should be 3. This should be 1, this should be 2, right? Because this is the first turn. The game state starts at 0. Okay, let's see. No, what happened was it was expecting 2, but it was 1. So this one is 1. This one is 0. But the game state here is 1. So the game state here should also be 1. Expected 2 to equal to 0. So this was 2. Oh, because right after this is the game state 1. After you play the game, it's going to be 2, right? And then this is going to be 3. Okay, things are making sense now. Right. It's a post assertion. Okay, I get it. So the test should pass now, and then we can move on to the next part of the tutorial. All right, excellent. Setup game, player 1 wins. Okay, sure. Okay, we're able to play the game. Let's move on. To avoid repeating yourself. Okay, so let's play tic-tac-toe. We'll play here row 1. So this is gonna be null, right? It's gonna be empty. And then what we're gonna do is we're just gonna race both players to just run. So I wanna double check that if I ran another turn using player 2, right? This is supposed to complain, right? This is actually not supposed to work, because it's not player 2's turn. It's supposed to tell me that you're not allowed. That's not your turn. Oh, this should be 4, by the way. Let's stop that. Anchor test. There we go. So it's saying it was expecting row 1, column 2. Oh, that's my bad. This should be column 1. Row 1, column 1. This should be row 1, column 0. Right, okay. Let's do that again. One-off errors, very common. Okay. Yep, it's throwing the error. You're not allowed to play that turn because it's not your turn, right? Player 2 can't cheat. You can't run 2 turns at the same time. Okay, excellent. So let's make this player turn 4. So we'll make this 5. And then we will just add this one. And then we'll just say player 1 takes another turn here. Right, player 1, row 0, column 1. And the game state should look something like this. Actually, let's copy this one. And then we'll say the person hasn't actually made the move yet because they're gonna make the move here. And then we're gonna copy this one again. Except this is 3, this should be 4. And then we're gonna take the final turn. So this is play turn 3, turn 4, and turn 5. And at this point, we would now win with just the X's. And this is play turn number 6, column number 2, right? 0, 1, 2 on row 0. Okay. Then it shouldn't be active. I think it wouldn't be active. I think it should now be like the game should be finished. Okay, so it was having an error because it was expecting something at line. So it was expecting 5, but it got 6. It was expecting 5 here, but it got 6. Oh, because the turn didn't increase. I think the turn didn't increase because the game finished, right? That's my understanding. So it should have an if statement here. Yeah, if the game state is active, then increase the turn. Otherwise, don't increase it, right? So what are the other options for your state? The game states is an enum, and it should have a game state of 1. Okay, is there a way for us to actually double check that? I'm not sure. Let's actually run it. I think there should be some kind of 1 or something, but we'll see what the test actually says first. There we go. It's saying 1, right? It's no longer the case that the game state is active, that you can still continue playing. The game state is now, this is the person that won. And I think this is just a reference to player 1, I think. Which has a reference to... what is a wallet? It's an interface. So I'm not sure if this is the correct way, so I'm just trial and erroring this, but we can probably just follow the guide. But I just want to try it out. Anchor test. %. That's my confidence level. I don't think it's gonna work. Yep, it didn't work. So it was saying it's 1. It was supposed to say pay winner, but then it said payer. So let's just move on and read the guide, right? Let's understand what's going on. Testing the play instruction works the same way. To avoid repeating yourself, create a helper function. Yes, we've used this. You can now create a new it test, set up the game like the previous test, but then keep calling play until you simulate a complete run of the game. So we did this, You can finish writing the test by yourself, or check out the reference implementation. Try to simulate a win and a tie. Proper testing also includes tests that try to exploit the contract. You can check whether you've protected yourself properly by calling play with unexpected parameters. You can also familiarize yourself with the returned anchor errors this way. So give it out of bounds. That makes sense. We use this to make sure we definitely throw an error. Should have failed but didn't. That makes sense. Then we expect it to be an anchor error, and the error should have a specific error code. Now, where are these error codes defined? ¿Dónde está? Error. Tic-tac-toe error code. How does it determine the number? So it was saying 6,000. Did someone say 6,000 here? I didn't say 6,000. Oh, here. Code 6,000. Oh, there we go. So there is a definition of your... Oh, it's automatically generated. Yeah, it's automatically generated. That's convenient. Thank you, Anchor. Yeah, okay. Okay. Okay, so another way to try to throw it out is same player in subsequent turns. We've actually done that already, so that's good. Deployment. Solana has 3 main clusters. For developers, DevNet and mainnet. DevNet is where you test your application in a more realistic environment than localnet. Testnet is mostly for validators. You're going to deploy on the DevNet. I don't need to test this. We can do this another time. Program directory organization. Program code. Eventually, some programs become too big to keep them in a single file. It makes sense to break them up. Splitting a program into multiple files works almost the exact same way as splitting up a regular Rust program. So if you haven't already, now is the time to read all about that in the Rust book. Yeah, they keep telling me, read the book. So it must be this one. Read the book. Yeah, okay. I promise I will do that. Okay, we recommend the following directory structure: lib, errors, instructions, and state. The crucial difference to a normal Rust layout is the way that instructions have to be imported. lib.rs file has to import each instruction module with a wildcard import. Instructions, play, asterisk. This has to be done because the program macro depends on generated code inside each instruction file. To make the import sure, I think this is something very important that I will have to remember, but we'll see if I do. To make the import shorter, you can re-export the instruction modules in mod.rs file in the instructions directory with pub use syntax, and then import all instructions in lib.rs file with use instructions. So it becomes publicly usable. I see. Well done. You've finished the essential sections. You can now move on to the more advanced parts of Anchor. Okay. I want to know what the game state would be. I want to know what would the game state be when we complete the game. I don't know what to put here in one. So they have a reference example. So let's look at that. It's archived by the user. We're gonna go to the unit test. Okay. Await play. Okay, this is the 5th turn. XX00. So we're actually doing the exact same thing. Okay. And then it's still gonna be the same thing. And then this one would basically 1, right? So if you're specifying the winner, you say 1, and then you say winner, and then player 1 dot publicly. Let's try that out. Interesting. Okay. Okay. So let's read the play command again, just to understand what's going on, right? So first, we access the program, we get the methods, we play a specific tile, and this player is the one that's doing it. Here's the reference to the game. This is the person that's signing it, and then we apply the remote procedure call. We get the state of the game, and then we check the state. It should match the received state. So I think that's a cool... That's cool. I think that's cool. That's a cool way of going through your development workflow. So that's neat. That's very neat. What else does this guy have for me then? Let's see. Because if we don't have anything else, I'm gonna start thinking about what I want to do. C-level attacks. So C-level is again the parallel processing runtime environment for the smart contracts. So Anchor uses a lot of magic to help eliminate foot guns. What does that mean, foot guns? Is a feature designed in such a way as to be extremely likely to cause problems. It's a great word because it puts blame on the design, not on users. Foot guns. Ah. Programming slang, humorous, derogatory. Ooh, so desu ka. Any feature whose addition to a product results in the user shooting themselves in the foot. Oh, today I learned. Cute. To act against one's own interest, to unintentionally behave self-destructively. Oh. Okay, so I'm gonna go ahead and retweet this one and say, I recently found the word foot gun during my study on Solana development. Okay. Solana development. Solana was Anchor development. Then it would be great if we also do a bit of marketing and just watch me study Web3. Watch me study Web3 and throw me hard questions. There we go. And that's gonna automatically post on my Discord. Man, I love automating my stuff. Okay, C-level attacks. It's important you understand every bit of the magic and the motivation behind it. A list of the common attacks can be found here, providing 3 different examples for each attack. Insecure represents flawed code that may be insecure. Secure, which represents a fix, and recommended represents a fix with idiomatic anchor code. Note that none of these examples are not necessarily secure, but they are meant to showcase a specific issue in a recommended fix in isolation. One can find some nice explanations here. It's strongly recommended to study each of these cases when building protocols on Solana. Yeah, don't worry, we'll get there. So let's read a little bit. Common security exposés. Okay, this is great because I really want to actually study nightmare scenarios on the blockchain network because I don't know what that's like. What exactly does happen? And I think we should probably have that kind of session eventually. Let's read together nightmare scenarios that happened in Bitcoin and Ethereum. Like, why did the forks actually happen? Those are stuff I've never studied before. So I think that's super interesting and we can explore it together. Okay. C-level attacks. So we go programs first, right? Signer authorization. Insecure. Ooh, there's a format. Okay, let's go insecure first. Go to source, lib.rs. So we declare the program signer authorization insecure. Then there's a function called log message, which logs the, let's say good morning. It tells us who the authority is. Okay. Not sure what I'm reading here. Let's go to recommended. Let's read the code. Okay, it says signer authorization recommended, right? The recommended was, what's the difference? Are you kidding me? There's no change. There's no change. Oh, wait, there is a change. Okay, it's there. Okay, so instead of using, the insecure one is using account info, right? This one is using signer instead. So this is recommended, signer. And I bet, oh no, I'm not even gonna bet. Let's just go read the secure. Okay. Derive accounts, account info. So account info. Okay. Let's read the explanation again. Insecure, flawed code that may be insecure. Secure represents a fix with idiomatic anchor code. Let's read that again. So this is just referencing account information But this one is saying that this needs to be the signer, I think. I don't know what signer means, and what you do when you don't know is you ask signer anchor Solana. What does that mean? What is signer? I don't know what signer is. Signer. Let's go back to Rust. Signer. What is a signer? Let's read it. This is the type that validates the account, that the account signed the transaction. Type validating that the account signed the transaction. No other ownership or type checks are done. If this is used, one should not try to access the underlying account data. Just double checking that this is the person that paid it. When creating an account within it, the payer needs to sign the transaction. Okay. Not completely adding up to me. Signer. Let's read that. What is a signer? Checks the given account signed the transaction. Player 1. It just has signer info. This accounts. It's just an accounts. And then it has a reference to player 1 because this is accounts. Because this is referencing the game. Because the context is for a setup game. The setup game has player 1, which is the signer, right? So the first player is the one who signed and initiated the game. He's the owner. Okay, that somewhat makes some sense. So what is this saying? This is saying that this is just a reference to somebody, but then you don't exactly know if this is the person who signed it, right? So that's why it's insecure. Okay, that's somewhat making sense. So this is saying, let's double check that this indeed is the person that signed it. And this one is saying, you can reference that it's an account info, but then if you are not the signer, then throw that there's a missing required signature. Otherwise, you can actually log the message. Okay, that's pretty cool. Let's read the next one. Let's look for an interesting one that we can read. Account data matching, sysvar address checking, owner checks. Let's do owner checks. Oh, hi. So this is saying owner checks insecure. It gets a Solana programming language or Solana programming library token account, and it's unpacking the account data, and you're just borrowing the data. You're not owning it. You get the token, and then you are checking if the authority key, if you are the signer, if the token data is double checking. Basically, the person that can only check your account data is if you are the owner. What's the change here on the recommended? Log message, your account balance is this thing. But then the constraint is actually enforced here as a, what's this? A trait? Is this a trait? I'm not entirely sure. It's saying that the account, the constraint should be that the authority.key matches the address of the owner. So these are cryptic Rust code that I still can't interpret, but we'll get there. It's just saying that this check is done at this level. What's the worst that can happen actually here? Because it actually does the if statement anyway. Why is this insecure? So the difference is this one would throw your anchor level errors, right? So this one would say if you don't match, throw the error. I like this actually. It's a lot more readable, less Rust stuff, but more readable, and readability is important to me. If the owner's ID does not match the SPL token ID, and if the authority key doesn't match, okay. What can we do? Account data mismatching. Let's read this. Okay, so we're checking for account, or matching accounts. Okay, so this is checking. This literally did not do any checks, except for this authority, I guess. It's checking the signer. But then it actually didn't use the authority, it just checked the account, the token data. Checked the token data, it borrowed the bytes, and then it unwrapped it into something, I don't know. Then it's checking the amount. So that's insecure. The recommended is there's that constraint, that Rust level kind of constraint checking on the token. And then it has to match that authority.key kind of thing. Okay. And that's it. It does that check already. It just displays it because it's fine. Okay. The recommendation here for Anchor is it doesn't have those weird Rust cryptic stuff that I still can't read, but then it's saying that you unpack the token, then you do your checks here and you throw an error, an anchor error. Okay. All right. I'm pretty good with example C-level attacks here. Probably just want to read what this commit actually did. Someone contributed and it just fixed the typo. A coconut. Okay, so this is just what they fixed. Interesting. Tada, you are now a contributor. Actually, let's double check that pull request that I submitted. Let's see if somebody actually replied to this one. Nope. No replies. Something to deploy a commit to Coral XYZ team on Vercel, a team member of the team 4 days ago. That's fine. We're not rushing. A lot of stuff to fix, but that's fine. Okay, so we are done with C-level attack. Oh, so is that it? I think that's it. Rust client. So those are just the references, stuff that we can potentially read. Okay. We're not gonna go out. We'll try to read a little bit of the core concepts again. Just see if we missed anything. There are two types of errors in the Anchor programs. Anchor errors are non-anchor errors. Internal errors that the framework returns, or the custom errors that you can return. You can access the error information. Let's see what that looks like. Ta-da! Broken. What is this? So there is a broken page, and let's contribute. Let's file a new issue. Is this the... Wait, just want to double check. Is this the Anchor application or is this the Anchor documentation? So let's double check if they have a contributing. Yes, they do. Thank you for your interest, all contributions, finding issues to work on, choosing an issue, issue guidelines, choosing a branch name that describes the issue while coding, submit a draft PR ASAP, only change code after coding. Okay, let's file the issue. So the issue is that this specific link is dead. Let's make a new issue. Dead link on Anchor errors, right? Summary, details, references, page in question, right? One of the links on the documentation is that I don't know where to find what it was referencing, so I can't make a PR for it. Details. This is the error page. I'm gonna take a picture, and this is a tool that I've been using recently, which is called I forgot, but I'll reference it after this cut. But I want to get it yellow, and then I want to highlight this one. This one's broken. Actually, I'm not gonna highlight it because it's broken. I'm just gonna wrap it around with red. This link, or maybe this link. I think that's very, very clear. Then we go here and we say dead link here, right? I think that's very clear. Okay. Ta-da! You are now a contributor. Dead link on Anchor errors documentation page. Okie dokie, we're done. Let's move on. In the Anchor client, like the TypeScript client. The TypeScript client also enriches the errors with additional information about which program the error was thrown in and the CPI calls. I don't know what CPI means, cross-program invocations, which are explained here, that led to the program from which the error was thrown from. The milestone chapter explores how all of this works together in practice. For now, let's look at the different errors can be returned. You can use require macro to simplify writing errors. The code above can be simplified to this. So if the data return an error, my error, data too large. Ooh, that's cool. There are a couple of required macros to choose from. When comparing public keys, it's important to use the keys variant instead of require equality, because comparing public keys with require equality is expensive. The program error. Okay, sige. I'm done with that. Let's move on and read something else. CPI. Often it's useful for programs to interact with each other. In Solana, this is achieved via cross-program invocations. So I had two programs a while ago, right? We had two programs. Program one. Well, I guess just one program. But aren't setup and play two different... Oh no, the setup and play are two different accounts. Because the game is an account, right? Which the setup actually configures. So setup game is an account and play is an account. Right. Okay. So cross-program would mean that's two different programs, I guess. Consider the following example of a puppet and a puppet master. Admittedly, it is not very realistic, but it allows us to show you the many nuances of CPI. The milestone project of the intermediate section covers a more realistic program with multiple CPIs, setting up basic CPI functionality. Create a new workspace, anchor init puppet, and copy the following code. Are we going to do this? Well, I have 15 minutes. Yeah, okay, let's do it. Let's do it. Make their CPI sample. Right, CD CPI sample. Then we're gonna do anchor init. This is gonna make a new folder. I'm not sure. Anchor init puppet. And I think I might slow down on the network because I'm downloading stuff. But that's fine. Okay. Public module puppet. Yeah, initialize, set the data, define some accounts, initialize, define the size needed for this account. The payer is the user, who is the signer. And it has a function called init, I think. What does init mean? And then it has another account called set data. I think each operation an account? Because it's an instruction? I'm not sure. There's nothing special happening here. It's just a pretty simple program. Okay, fine. I'll read it. So what's happening? We have two accounts. So they are data structures that hold data. One of them is called initialize. One of them is set data. These are actions, verbs. So they actually are supposed to do something. So I'm assuming that initialize actually configures the data that needs to be played with. So like data, right? So this is the puppet called data. We have the user. Then we have some system program. And then we have another set data, which is a puppet. Okay, things aren't making sense. There's nothing special happening here. It's a pretty simple program. The interesting part is how it interacts with the next program we are going to create. So anchor new puppet master. So anchor init puppet master. Inside the workspace, copy the following code. Set data. So if you're the puppet master, you have a function called pull strings. And you can specify the data, which is an unsigned integer of 64 bits. And you have the account. You get the puppet program. You get the account info. Cross program invocations. Then you call the set data function. Of the puppet. You call the set data function. Then you specify the puppet, which is this specific puppet. CPI context, CPI context. This is CPI program, this is your CPI accounts. And then the puppet calls the set data functionality. Derive the accounts, pull strings. Again, it's an operation, it's an instruction. Also add the line puppet master in the programs.localnet section of your anchor.toml. Finally, import the puppet program into the puppet master program by adding the following lines to the dependencies section of cargo.toml. Okay, let's do the copy pasting we're supposed to do. So let's open this whole thing up. Let's close this one. Put this here. So on puppet, let's go to the programs source lib.rs. Copy this whole code, right? And we slowly do the same thing for puppet master. We'll read it afterwards. Slap it on there. And then it's saying add this line in the programs for anchor.toml. Right? Actually, I'm not gonna overwrite it because I don't know what's there. I'm just gonna comment it. And then finally import the puppet program under dependencies on your cargo.toml. The puppet can be found on /puppet. The features equal CPI is used so we can not only use Puppet's types, but also its instruction builders and CPI functions. Without those, we would have to use low-level Solana syscalls. Fortunately, Anchor provides abstractions on top of those. So basically, Anchor makes it a lot easier to do these cross-program invocations. So we're importing those libraries. By enabling the CPI feature, the Puppet master program gets access to the Puppet : CPI module. Anchor generates this module automatically and it contains tailor-made instruction builders and CPI helpers for the program. In the case of the Puppet program, the Puppet master uses set data instruction, which is this one. The Puppet master uses the set data function of the Puppet application, Puppet program. This function has the exact same function as set data function in the Puppet program, with the exception that it expects a CPI context instead of a context. That's why it provides a CPI context. Setting up a CPI can distract from the business logic of the program, so it's recommended to move the CPI setup into the implementation block of the instruction. Donde? Where? The Puppet master program then looks like this. So we have the Puppet master program. Looks like this. Pull strings. So where do we keep the setup? So we define some implementation here. Okay. And then this becomes, so this one becomes, it generates a context, set data context. It generates a CPI context. A CPI context of I don't care. Okay, so CPI context, this is what we need. But what's this one? This is an implementation on the... So this is what we're building. It just calls context accounts. Context.accounts. And then set data. Then this whole thing disappears. Because we get the context accounts and then we do all of this processing. We reference the Puppet program to get the info, we set the data. And this whole thing just went here into the implementation. Then it became a method. So this was saying I want to define a method on the pull strings struct. And it is a public function which can be accessed externally, called setDataContext, which has a reference to the self and it returns a CPI context. Then this is the logic. And then we just remove all of this. Okay. Makes sense. We can verify that everything works by replacing the contents of the puppet.ts file. What's your problem? Failed to load manifest. Cargo toml. Is this gonna work? Is this gonna work? Is this gonna work? So we need to reference the puppet properly. Let's see if we can reference this one. Copy path. Does that work? Apparently it does. Okay, let's move on. We have 4 more minutes. I think we're not going to be able to complete this, and that's perfectly fine. But this looks interesting. Yeah. You can probably resume this later. But this is a little deep because I'm not entirely sure I'm going to be building programs that interact with other programs yet. So I'm not entirely sure if I actually want to proceed with this. But for sure, we basically went through the tic-tac-toe sample project of Anchor, and that was pretty good. Yeah, cool. Nice. All right. We'll probably end off there. And we could probably talk a little bit about some of the things that I want to share with you guys. There's this really nice YouTube channel called 3 Blue, 1 Brown. I don't know if you guys have heard of that. But they make beautiful visualizations of mathematical and computer science topics. 3 Blue, 1 Brown. And I'm super excited because I might very likely be